Hi everyone, we are going to continue with our past papers 1, 2. What does mean 1, 2? Past paper 1 and question 2. Grade 12 physics. Today's topic is mechanics with 16 marks. So we are going to carry on. Please go to link and get questions and try first. All right, let's see what they ask. We have 20 kg object, all right, and then we have applied force F. How many newtons? We don't know. Okay, constant force. And then they said constant velocity, moving with constant velocity. It means acceleration is 0. And then we have frictional force 18 newtons on the block. All right, so all givens. And then we have inclined system with 30 degrees. Okay, let's see what they ask. First of all, state Newton's first law in words. Okay, that's our question 2.1 with 2 marks. Okay, let's continue. So all definitions here, please get from list. Try to memorize all definitions, plus minus 40 definitions you have in physics. So we should know them all. Newton's first law, second law, third law, we should know them all. And then, so first one, Newton's first law is here. A body will remain in its state of rest or motion at constant velocity unless a non-zero resultant or net force or unbalanced force acts on it. Or you can use another one. Please try to memorize all definitions. All right, let's continue. It is your job. All right, please just write it down or read again. Just try to keep in your mind all definitions. Okay. So next one, draw a labeled free body diagram for 20 kg block. Okay, this is our question 2.2 with 4 marks because we have 4 forces. All right, how we are going to draw? First of all, you just use a point here and we have applied force as you see. First of all, you can draw on object. Maybe you can just draw on the system on question paper. You can just show all forces on the system first, and then it's going to be very easy. You can use W or FG already given here. So all symbols, this is gravitational force, always going down. And then you have friction force parallel to surface. It is 18 newtons. Friction force, how we know, it is just going down, friction force, because block moves up. All right, block moves up, friction force always opposite direction of motion. Okay, we have friction force, and then of course we have what else? Normal force, perpendicular to surface. So friction force parallel to surface and normal force perpendicular to surface. We have 1, 2, 3, 4 forces. And then you are just put dot here and showing, please be careful about that. If you draw normal force, just opposite to, just opposite, just going up like this, it's gonna be wrong. Please be careful. Maybe you can draw helping line for you. Just put dot and just draw helping line with pencil, or you can draw and then just perpendicular to surface. Normal force always perpendicular to surface. Just remember our question 1, I think they ask about this one, right? Normal force, define normal force. So other question I remember. And then, so friction force and rest of them, gravitation force always going down. Just be careful about this because some learners doing that mistake, just going up normal force for inclined system and getting -1 mark. So they said except force diagram like this, or except this one, just getting components for gravitational force. So gravitational force parallel and perpendicular, but there's another important point. If you draw gravitational force also here with components, you are gonna lose your 1 mark. It means you are getting extra 1 mark. If you are showing gravitational force alone, it's fine. If you are showing components, it's fine, but not together. All right, please be careful about that. If you show them together, it's going to be wrong and you're getting -1 mark. This point's very important because it's already written here. Normal force Where was it? If you have extra force, -1 mark. Maybe another paper it was written. Just it was. Okay. So let's continue with any other symbols you can use. It was easy one. Just I want to explain some details because very important. Some learners losing mark because of these kind of things. Okay, free body diagram done. Let's continue with next one. Yeah, already here. Okay, I was talking about this. Mark for label and arrow. If you just label them, if you just draw free body diagram with symbols, you are not getting full mark. You should write what is W, just you should write gravitational force or FG, gravitational force, or any other symbol you can use, but you have to write name of force. All right, F is applied force, and FK or small f only friction force. If you just say friction is fine. And then N or Fn or normal, you can write after calculation, you can write this, or you can just say normal force, it's fine. But we should write names all, otherwise -1 mark. If you are adding extra force, also -1 mark. I think that's enough. But it's not necessary if you are doing longer or slower, just they said don't penalty. Okay, you are not losing your mark for arrows, short or long one. All right, question 2.3, 2.2 done. 2.3 now. So 2.3, they said calculate the magnitude of force, apply force. That's our question. So what we know, constant velocity, acceleration is 0. Acceleration is 0. If you have acceleration of 0, you are using Newton's first law, right? So you can say F net equals m times a is 0, so F net equals 0. You can write, and you are getting your mark. Or, so you are using all forces, okay, on the object to calculate force. So first of all, any of this formula you can write. This is our first option. And they said 18 plus 20 times, so FT for, okay, let's show on the system and it's going to be much easier for you. So what we have friction force, right? We have friction force F this way. And then we have gravitational force this way, but we are going to use parallel one. So as you see, for just parallel to surface, what we have applied force and gravitational force parallel and friction force. Another force do you have? No. So you are writing Newton's first law, F net equals m times a, or F net equals 0 directly. This is Newton's second law, but acceleration is 0, directly change to Newton's first law. F net equals 0, then you are getting your mark for this. 1 mark for formula. You can write this one. So F plus F friction plus F parallel is equal to m times a, or 0, you can say, it's fine. And then F plus minus Fk. So all details here. I like this one because differences giving you. So F net equals m times a, or directly you can write 0. It's fine. So F minus F friction plus F parallel. So this, how we are getting this formula? M times G times sine 30. Okay, m times G times sine 30. Maybe we can write here because it's complicated. It looks complicated, but it's easy one. F net is equal to 0. And then F minus friction force plus gravitational force parallel one is equal to 0. I think it's much better for you like this. Let's write it down. And F equals, can I just take all negative side, other side, just take this side, F plus F parallel, is it fine? So friction force is equal to F plus F, friction, gravitational force parallel. So let's write F equals, friction force is already given, 18, plus, for gravitational force parallel, how can we write? M times G times sine 30. Okay, for inclined system, parallel formula is here. We should remember that. And F equals 18 plus M is what? 20 times 9.8 times sine 30. After that, you just calculate and you are getting 116 newtons. All right, I think it's okay. Just using Newton's first law, or second law, just write the acceleration 0 and change to 0, it's fine. And then you say, so which one is going up, what force is going down, and then you are just writing one equation, and then you are getting apply force. I think it's okay. And we have other options. If you want, just check. If it's okay for you, you can use other options, but I like this one, it's the easy one. Just use this one, guys. So you can use another formula here, energy from change and work energy formula, or we have another option. Let's see. Oh, we don't have, okay, just that option. All right, let's continue with next question. Now they said write down the net force acting on the block as it moves from X to Y. Okay, so now kinetic friction force acting on the 18, it moves from point X to Y. Okay, so that's our question 2.4. Now you remove apply force. Force F is removed when the block reaches point X. Okay, just apply force using till point X. When object is coming to point X, F apply force is gone. And then after that, what's going on? Block continues to move up force and come rest. Okay, final position at Y. Velocity is 0 because you have force just pushing up, and then because of friction slowly getting slower, and finally stop at point Y. And then they're asking you write down the net force acting on block as it moves from X to Y. Let's see how we are going to calculate it. Positive marking from question 2.3 because you calculate force already 116 and F plus, because using same force, because of friction force, down inclined system, opposite, because getting slow, getting just slowly slowing down, and then finally stop moving. So 116 newtons. 116 newtons. You can ask. Apply force, F is removed, but still 116 newtons. Why? Because when you remove this applied force at point X, okay, let's say point X is here, just take X here. Okay, so still you have friction force. Still you have gravitational force, parallel one. So even if you remove that, but now you have net forces, these two, even here, say friction force plus, we calculate already them, so 116 newtons. And direction downward. That's it. Okay, 2 marks. If you want, you can recalculate, but we don't need that. Friction force is 18, and then F parallel is equal to m times g times sine 30. I think it's okay now, because when you apply force, still you have gravitational force, parallel, and friction force. Object is slowing down, and then finally stop moving at point Y. All right, let's continue with next question. Let's see what else we have. Calculate the distance between point X to Y. Okay, between X and Y. So now slowing motion, just slowing down, it means we have motion question. In mechanics, we have motion question. How can we calculate? We have different options. Option 1, first of all, you are getting acceleration for that. F net, you know already. We said F net is equal to 116, and then equals m times, say, from Newton's second law. M is 20, so acceleration is minus 5,80 meters per second square. And then now you know acceleration, and then you can use any formula, equation of motion formula, maybe this one without time. So V final square is, I like this one, it's an easy one, because otherwise you should calculate time first. So V final square is equal to V initial square plus 2 times A delta X. This is our formula for motion without time. V final is 0. How we know that? Because they said stop at point Y. So to rest at point Y. So V final is 0. V initial is 2. V initial is equal to 2 meters per second, because it was coming with constant speed, constant velocity. Do you remember? It is given here 2 meters per second. And plus 2 times A you calculate already from Newton's second law and getting distance between X and Y. This is easy way. Or you can calculate V final is equal to V initial plus delta X. You can get time first. And then you are using another or using this formula to get time first. You have different options, of course, just like other questions. You have different options. You are getting time first. And then you are using another formula, another equation of motion formula, but I like first one, nice one. All right, so question 2.5 also done. I hope everything is fine so far. Let's continue with next one. Let's clear. Are we done for today? Yes, so other options, more options coming for question 2.5. As you see, we have 5 different options. You can check them all, because I will leave link with you, and then you can just check all, which one is easy for you, which one is okay for you. You can use that option. So we have done for today. Thank you very much. See you next lesson with next question.